In this lesson 4.6, we are going to move into working with imaginary units, or what's called an imaginary number. The imaginary number that we're going to be working with is the square root of -1. And we know from past mathematics that we can't take the square root of a negative number. It's not a real solution. And so what we use to represent the square root of -1 is a little letter I. Okay, it's this little italics I that looks just like that. So when we factor out a negative 1 out of the square root from under a square root sign, we're going to call it I. The other thing that we are going to use in this section is I squared. All right, so if I wanted to square this right-hand side, and then in effect, I also have to do the same thing to the left-hand side. I have to square the square root of -1. Well, we know squaring a square root gets rid of both of them, and we just end up with what's under the radical. Okay, so if we square both of them, both sides, this is what we end up, I squared equaling -1. So we're going to use both of these as we solve these equations over here on the worksheet. On number 1, they've told us that x squared equals -36. So I'm going to solve for x by taking the square root of both sides. All right. When I do take the square root of that -36, I have to remember that it could be the positive square root or the negative square root. So I need to write that plus or minus out there. The square root is going to cancel out the exponent of 2. So I am left with just x. And then I have plus or minus this -36. If I rewrite -36 as the product of -1 times 36, you can see under there that I have the makings of I. We're going to need I, the square root of -1. So watch what I can do. I can take each of these numbers under here and put them under their own radical. Okay, so I end up with the square root of -1 times the square root of 36. Well, according to our definition, the square root of -1 is I, and we know that the square root of 36 is 6. So x equals plus or minus, don't forget that plus or minus, 6i. You just bring them straight together because they're being multiplied together. And this is the final form of that answer for number 1. On number 2, we want to solve for x. The first thing we have to do then is get that x squared by itself. So we'll take that 121 to the other side by subtraction. We're going to go through the same process. I'm going to take the square root of both sides. I need to put that plus or minus in there. I had to scrunch it in there a little bit. The square root cancels out the 2 exponent on the x, and we just end up with x. Plus or minus, and I'm going to rewrite -121 as a product of -1 and positive 121. All right, when I do that, I can separate those out, each under their own radical. So right here we have the definition of I, the square root of -1. I'm going to set that right here because we usually put the coefficient on I first, which would be the square root of 121, which is 11. So I'm going to set that right in front of I. All right, same process on number 3. We need to get x squared by itself. I'll do that by subtracting 9 off both sides. I'm going to take the square root of both sides, remembering to put that plus minus next to the square root of -1. And so now we see that when we rewrite -5 as a product of -1 and positive 5, we can separate those. We have the square root of -1, which is going to be I, and then we have the square root of 5. 5 is prime. So because 5 is prime, there's nothing left that we can do under that radical sign. So the way we write that then is plus minus the square root of 5i. On number 10, we have two sets of parentheses being added together. So since everything is being added together, we can remove the parentheses. And then we're going to add hang on, that is plus I. And then we're going to add together the terms. So you can see we've got two imaginary units. An I and an I added together is as simple as it sounds. It's just going to be 2I. And then we add our constants together, and that gives us 2I plus 4. If you had 4 plus 2I, that's okay as well. Either one would be correct. On 11, same idea. We've got addition and subtraction only. So we can remove the parentheses. And in doing that, now we can add like terms. So we have two constants. We have a 4 and a 2, two whole numbers, rather I should say. Two whole real numbers, and then we have two imaginary units. We have a negative 3i and a positive 6i. These work the same way as just adding real numbers. You're going to subtract the 6 and the 3 because they have different signs, and you're going to take the sign of the higher one. And then don't forget the I there. Number 12, same thing. We will drop the parentheses. However, we have to recognize the fact that this is subtracting the 4 and that 5i. So we in effect have to change the signs on everything in that second parentheses. It is minus 4 and then minus a positive 5i. All right, which in effect is minus 5i. Okay? So we're just changing the signs just like you would in any regular problem that had all real numbers. You're doing the same thing with those imaginaries. All right, so now we've got all our parentheses removed and we've got our signs correct in that second set of terms. And we'll do the same thing again. We'll combine like terms. So we've got two real numbers, a negative 4 and a negative 4 gives us negative 8. We have two imaginary, they're both negative. So we'll combine them to give us a negative 6i. All right, 13. You have a plus a negative 3, which is the same thing as minus 3. And then you have plus a negative 6i, same thing as minus 6i. Okay, combine like terms. 5 minus 3 will give us 2. Negative 3i, negative 6i will give us a negative 9i. Now 14 is going to require us to distribute. So just as we distribute real numbers, we're going to distribute that imaginary unit. 3i times 4, we are going to multiply the 3 and the 4 together to give us 12i. Then on 3i times 2i, we're going to multiply the 3 and the 2 to give us 6. And we're going to multiply I and I together to give us I squared. So right there you see that definition that we need to use for I squared. At the beginning, when I gave you the notes at the very beginning of the video, I said that I squared equals negative 1. So we can simplify this. This right here is going to stay 12i, but this is 6 times negative 1. I'm pulling that I squared out, and I'm going to plug in negative 1 because we can simplify it with that negative 1 because we know what I squared equals. So then we end up with 12i minus 6. Okay, so moving to 26, they ask us to find the absolute value of the complex number. Now, the reason I probably should stop here and explain what a complex number, how that's actually defined. So a complex number is any number that has a real part to the number and an imaginary part. So in number 26, 3 is the real part of that number, and the minus 4i is the imaginary part. They both go together to make the complex number. So a complex number has a real part to the number, and it has an imaginary part. All right, and you are going to be able to recognize the imaginary part because of the little italics I that we're using to represent the square root of -1. Okay, so they want you to find the absolute value of this complex number. And the way that it is written out as a formula is the absolute value of z. Z stands for complex number. So it's the variable they're using to indicate that they want you to find the absolute value of a complex number. So when you want to find the absolute value of a complex number, it's not as easy as just a real number. You have to follow this formula where you take the complex number and put it under a radical, put specific parts of it under a radical. All right, and so here's the formula where z equals the complex number. Okay, so in number 26, that would be 3 minus 4i. I'm just subbing in 3 minus 4i for z. A is going to stand for the real part of the complex number. Okay, so in this case, the real part of that complex number is the number 3, and we're going to square the 3. And then I'm going to add to that the imaginary part of the number, which is only the number part. We leave the I off, okay? So we want for B, we want the imaginary part without the I, okay? So we're not going to stick the I under there. We're going to take the 4. And as a matter of fact, this one is a -4, and we're going to square it as well. Okay, so you're taking the real part, you're adding to squaring it, and then you're taking the imaginary part and squaring it. So under the radical, I'm going to end up with 9 plus 16, which gives me the square root of 25, which gives me 5. So the absolute value of this complex number 3 minus 4i is 5. All right, let's try that again with number 27. So I'm going to take the absolute value of this imaginary number 1 minus I square roots of 3. All right, I know it's a complex number because it has a real part 1 and it has an imaginary part minus I square roots of 3. So I'm going to put the real part of the number 1, replace that for a. I'm going to square it, and then I'm going to take, leaving the I part off, I'm going to take the square root of 3, actually the negative square root of 3, and I'm going to square that. And all of this is under the radical. So I have the square root of 1. Right here, I've got, I'm squaring the square root of 3. Okay, so when I do that, the square root sign and the exponent of 2 go away to leave me with the opposite of 3. Sorry, that's a positive 3, rather. Let me do this. It's a positive 3 because when we square a negative number, a negative and a negative gives us a positive. And then squaring that square root sign, they go away. So we end up with a positive 3. All right, I don't really need those parentheses there anymore around that 3 because we now have the square root of 4, and we know the square root of 4 is 2. So our absolute value for this complex number is 2. Now we can also plot numbers in complex numbers in what is called a complex plane, and you can see that in 29 through 31. We have a real axis that looks is right in the place where our x-axis normally is, and we have an imaginary axis, which is where the y typically is. This is not the same kind of a plane that we've been doing. This is not an xy plane. This is a complex plane. So there's a real and an imaginary axis, and we're going to plot this complex number of 3i. So the way that works is you have to take the real part of the number and you use that as one part of the plot point, and then you use the imaginary axis. In 29, we have a 3i. That's our imaginary, but we don't have a real part of the number. All right, in 30 we do 2. We have 2 as a real part, and we have 2i as an imaginary part. So over here, because it's not listed, it's not written out, we know it's 0. We're not going to write 3i plus 0. If it's 0 is the real part of the number, we don't have to write it out. It's just assumed to be 0. So we stay right here at 0 for the real part. We don't go over here. It would be like as if x were 0. And then we're going to go up 3i units. And that would put us, here's 1i, 2i, here's 3i. And there's that point. That's the complex number plotted, 3i. Do the same thing on 30. Here we have a real part though. So we're going to go over to 2 on the real axis, and we're going to go up 2i on the imaginary axis and plot our point there. All right, and then in our last 4 problems, they're asking us to use our properties of exponents to write those numbers, those complex numbers, in standard form. So in essence, what we're going to do is we're going to simplify it if possible. And in number 32, you see that you have an I squared. Well, again, we defined I squared as -1. All right, so just to review that, at the beginning I gave you those notes. You really need to write these down, is that if you didn't at the beginning, I is representing the square root of -1. I squared, if we square both sides, then that lets us know that I squared equals -1, the real number -1. Over here in number 32, then, we can rewrite I squared as -1. So now we don't have 2 plus I squared, we have 2 plus a -1, so we're just simplifying it, and we get 1. Okay, that's the real number 1. In 33, we have 3 plus I cubed. Now, we can just forget about that real part of the number for a moment, and we can rewrite I cubed using our properties of exponents. We can rewrite it as a product of I squared and I, right? Because when we multiply exponents together, we rewrite the base. As long as the base is the same, we rewrite the base, and then we add the exponents together. Okay, we can do the same thing when we separate them out. Now we have an I squared, something that we can define in a real way. So we've got 3 plus, I'm going to sub that -1 in for I squared, and times my I. Following order of operations, I'm going to do this multiplication right here first. -1 times I gives me -I. So I end up with 3 minus I. And that's just a simplified version. We've taken that complex number and put it in standard form, meaning we've simplified it as best we could. Number 34, we can do the same thing. Just forget about the real number for a moment. We can rewrite I to the 4th as I squared times I squared. All right, I'm going to put that in parentheses because that negative number right there, and we need to take care of the multiplication before we do anything else. Well, now we have 2 I squareds. They both represent a -1. So I have -1 times -1. I'm just replacing the I squared. -1 times -1 in that parentheses gives me a +1, and then I'm going to subtract that from that 5, which was the real number portion, to get 4. Same thing here. Just rewrite that real part, and we'll come back to it in a moment. We're going to rewrite this as I squared. Oh, I'm going to put it in parentheses again because I've got this subtraction sign here. I squared times I squared times I. All right, 2 plus that 1 gives us an exponent of 5. So I'm just rewriting I to the 5th in a different form. Now I have 2 minus, in parentheses, -1 times -1 times I. I'm going to do what's in parentheses first there. I'm going to end up with a positive I. -1 times -1 is +1 times that I will give me 2 minus I for my final answer.